And hi to everyone. As promised, I'm going to do a short video for each of your sub chapter. So, like in our module 4, we have several subtopic. If you look over here, we have first is our introduction. Wait, sorry, I need to change it to pen. Okay, because I love blue. We have 1.4, which is our introduction, and then we have 4.2, which is under missions, instructions, and also the characteristic. And next we have 4.3, types of operands. 4.4, addressing modes. 4.5 is under your instruction and also formats, and lastly of course your summary. So from all of this, I will do a short video. So maybe if let's say 4.2 4.1 is only small part, then I will combine it together between 4.1 and 4.2. And then if this one is already long enough, then I will make separate for 4.3. So let I start the video. Okay, first of all, under introductions, what we're going to look into ISA. What is ISA? ISA is instruction set architecture. So what we're going to look in the introduction part is overview, hierarchy of the computer language. This one we already covered in our class, but yeah, of course, I want you to understand more clearly. So why not you repeat again and then you see this video. And under general concept, x86 processor. Last time I think I did ask you in the class what is basically x86, and you already know it is the processor for 32 bits, for 32-bit system under your processor. And going to look into the general concept for the architecture. Next, we're going to look into the design decision for instruction set, and lastly the ISA level. So this is basically what we're going to look into the introduction part. Okay, this is the overview. Of course, I'm not going to read all of this because reading is nothing compared to teaching, right? So on the overview, what we're going to look is under our ALU, the overview for our ALU. The keywords that we need to see is what we're going to look is one boundary where the computer designer and computer programmer can see. That is what you're going to learn. So this one, computer can see, your designer, you as a programmer also can see, the computer designer also can see, which is view the same machines is the machine's instruction set. So this is just about detail or the meanings of machine's instruction set. And after that, you can see also still under your machine instruction set, which is what you're going to implement. And the third sentences is basically on your correlations between your machine's language and also assembly language. Later on in our next slide, we're going to look into your machine language, your assembly language. You're going to learn on assembler, and your compiler. This one we already looked into our class, but I hope that you can repeat again also and look into this video. Some of the question might come out into your mind. Why you need to learn CoA subject? Of course, this is the big question marks. And then in this module 4, in this module 4, what you're going to learn? So if you look into the overview, you need to learn about assembly language. So what is basically assembly language? Why you need to learn assembly language? And what is the difference between machine language and also assembly language? Is it similar? Is it different? So what is the relations between assembly and also machine language? And previous slide, I did also mention about assembler. I did also mention about the compiler. What is the compiler? What is the assembler? And how the assembler related to your high level language? What is your high level language? Basically, the example like your Java, C#, you have a lot of others like Python, C programming, C++, and many others high level language. So what is the correlation between each other? And is it your assembly language is portable or not? How about your high level language? Is it portable or not? So all of these questions might come out into your mind. So that's why we will try to figure out and learn all of this. So this one is under your hierarchy of your computer language. So you have two big separate, which is under high level language and low level language. What is your high level language? High level language, you have the high level language, of course, and on top of it, you're going to have your application, your program. Let's say your window. What else you have in your computer? You have also, of course, this is Microsoft. You have a program, pen. You have your Google.
It's 22 hours.
You have your Firefox. A lots of program that available in your computer. And in your computer, before you can have all of these applications, you need to have the high level language. So this high level language is machine independent. And below of it, before you can run it using your computer, which is under your hardware, because this one is mostly a software, you need to have several steps, which is from high level language, you need to have assembly language. But after this, you can see also there is a correlation between correlation between your high level language and also machine language. But throughout all of this is the level. Okay, this is your computer, which is your hardware. Inside your computer, they have the processor of your program control. And after that, before you can have any kind of programming, any kind of language, you need to have machine language, because this is the only programming. This is only programming or language that your computer understand. Similar to us. Let's say we are Malaysian. we are Malaysian, and mostly if let's say you are Malay, you know the Malay language, and of course because you already learn English, because you know also you will know also English language, and maybe you learn also Mandarin, so you can list all whatever language that you understand. But throughout, for your computer only understand machine language. So but as human, wait, I delete first. Okay. As human, you cannot understand machine language. You cannot understand, because normally machine language is like 10110010. What is this? Of course you don't know. Maybe you just say hi, but it's come out like this. Of course you're not going to understand. But computer only understand machine language. So you need to have something, some language that can change and have interconnection between machine language with another language. Then you can use this language to do some programming and etc., to connect and convert it into the machine language after this. So it called as a assembly language. Assembly language is the very basic language from all language that available. So you need to learn assembly language first. When you have the knowledge for assembly language, then it's easy for you to learn also high level language. It have several similarity, like it's going to have library, it's going to have a variable, it's have integer and so on. So you learn it all in your basic assembly language. So this is just hierarchy of your computer language. Next, you're going to see the differentiation between your assembly language and also your machine language. Okay, you can see over here, you have machine language. It is a native to a processor, which is it going to execute directly by your hardware. Your computer, your processor will execute directly because they understand machine language. And the instruction consists of binary code. As I mentioned, it's normally is going to be like 1010001111, which is I also don't understand. So that is on your machine language. Now you have another one, which is assembly language. Why and what is the difference between machine language and also assembly language, and why you need to have this? Okay, so assembly language is a program language that use symbolic name. Like your machine language is going to use like 0101, which is you also don't know what is basically here. When you want to have like you want to create a program that can make a calculator. So of course there will be additions, subtraction, multiplication, divisions. So all of these normally it's going to be like a symbolic name, which is symbolic name represent the operation. This is operation. What symbolic name? Normally you will use ADD, isn't it? To represent your source code, your code as a addition operation. If you need to do the subtraction operation, you also have the symbolic name, which is SUB. When you want to move and everything, so you're going to use a symbolic name, which is your source code. So you're going to have several codes inside your source code. You have your own programming, and you also use the symbolic name to represent your register and represent your memory location, your addresses, your EAX, your EBX, all is related to register also. So you represent it in terms of symbolic name. And after that, what else? It slightly higher level language, which is of course slightly higher than your machine learning machine language, ML, machine learning. Okay, it's readable, so means that you as a programmer, you can read. Of course, you can read, you can understand. Sometimes it's not fully 100% understand, but still you can try to figure out, like MOV, what is the MOV? Of course, it's move, like add, what is add, and etc. As mentioned, is a readability, which is it can be readables of instructions. Is better than machine language. Of course, if you want to compare to machine language, you cannot understand it. So it is much better, and it is one-to-one response with your machine language instructions. So you have the correlations one-to-one between your machine language and also your assembly language. So this is between your machine language and your machine language and also your assembly language, yeah. Okay, now over here it is come for you to look into compiler and your assembler. You have high level language, you have Java, you have C#, you have Python, many others language that you have. And you also have assembly language, and of course your machine language, because you want to connect it and to compile it directly using your laptop, let's say. Over here, your Java, your C, your Python, and whatever high level language can directly be converted direct to your machine language by using your compiler. So this is the purpose of your compiler, which is it's going to compile your high level language to be your machine language. Next, you have another task using your compiler. What it is? So it's going to compile and it's going to be changed to your assembly language. So now you can see your compiler can convert it directly to your machine language, and it also can compile and convert it into your assembly language from your high level language. So this is the use for your compiler. Is it okay? Now for your assembler, the only task is it's going to convert your assembly language to your machine language. So your assembly language, if you want to convert it to your machine language, you're not going to use your compiler. You're not going to use compiler, but you're going to use assembler. You're going to assemble your assembly language to be your machine language. You're going to assemble it. So now you can see the overview and what is the functions for your compiler and also your assembler. Over here you can see there is also description. Compiler translate your high-level program, your high-level language to machine code. You can see you will be converted into machine code, which is translate to machine code. You have two way. Either it directly, you can see direct, or it is indirect. How are you going to indirect? Which is you're going to compile it to assembler language first, which is indirect using via an assembler. You compile it, go to the assembly language first, and from the assembly language you're going to use your assembler to be your machine language. So this part, it is the indirect, while over here it is a direct, which is you direct change. Next, you have the assembler. What is the assembler? Which is you translate your assembly language, assembly program to your machine code. So this is the function in terms of sentences, and this is in terms of a graph of a picture flow. So okay, right? Next, you can see the advantages of your high-level language. It have advantages. What is the advantages? So first of all, you can see your high-level language development is faster. Why? It faster because it have fewer instruction to code. If you have a source code, you can see maybe you occupy only 1 or 2 paragraph. Is it a paragraph? Yeah, a line, 2 line, 3 line. So it's just a few, let's say 3 lines. But if you use your assembler just doing a similar program, you're going to occupy, let's say, 10 lines. So you will take note that it is a fewer instruction. If you have fewer instruction, of course it's going to be more faster, because you're going to your computer will read line by line. So when you have 3 line, of course it's going to be finished ASAP rather than if you have 10 lines. Next, second the advantages, which is program maintenance is easier. It's easier for you to maintain it because you have 3 line only. Then it's easy also for you to, let's say you want to change the second line, or maybe you find the error. Then you know, okay, it's easy for you to find out. Rather than if you have 10 or more than 10 line, so you need to change one line. You need to figure out where is the error, where is the warning, what is happening in your codes, and etc. It's going to be quite high rather than using your high level language, which is normally have a fewer instruction code, which is the same reason as above. So these advantages already look into. Now another advantages, you have this high level language is portable. What is the meaning by portables? Portable means It can be used with a little or no modifications on the different machines. So if you have like, I just give an example, okay, let's say you have a window. This one is X 68 32 bits, and you have X64 machines. So when you have Java programming, when you move to another new machines, so sometimes no need for you to do any modification, but sometimes when you move you need only little modification. But when you are using assembly language, there is a big differentiations that you need to do, especially on the modification of your source code. That is called as assembly language is not portable. A compiler translates to the target machine language, which is your compiler can translate directly to the target of your machine language, which is portable, whether you want to directly change it or you want to change step by step also, it can. So that is on your high level language. So I hope that you understand at this phase. Okay, now you can see you have the assembly language. So why assembly language? It accessibility to system hardware, which is useful to implement system software for your assembly language. It also useful for small embedded system. If you want to create a small program, it's going to useful to use the assembly language. And space and time efficiency. Why? The understanding of your source code is much easier. So program in inventions, tuning the program performance, writing compact codes. So this is assembly language, the advantages. And there is another two. Writing assembly program give your computer give you, which is you as a computer expert, needed deep understanding. So when you learn assembly language, you're going to have deep understanding in the instruction set on how to design. Second one over here, you have also when you know how to write your assembly language, of course you're going to able to write compiler for your high levels language, which is you need to be expert with the machine language using high level language. Before you're going to be expert, you need to learn on assembly programming, so that you have the experience on how to do it, because it is a basic programming. We still under 4.1. This one, we have the processor of x86. We're going to look into the architecture. So in these sections, you can see that you're going to look into your x86 processor family, and it hosts computer system from programmer point of view. This is just description what you're going to look in this section. And under assembly language, it is a great tool for learning how your computer works. So first of all, you're going to see how your computer will work and require you to have no working knowledge of your computer hardware. And then still under general concept, the concept in this section, what you're going to learn, is going to help you to understand the assembly language code that be written. So you're going to learn on assembly language code. Okay, this one, we already looked into this architecture. You have basic microcomputer design. Wait ah, sakit pinggang. Okay, you have basic microcomputer design. This one is the block diagram of your microcomputer. As I mentioned, it is very important for you to have bus. You have several type of bus. You have data bus, you have over here control bus, you have address bus. And what is the function of all these bus? It is to connect between the elements in your computer. So you have the CPU, you have your memory units, you have the input output device, and all of these need to be connected using your bus. If you want to doing exchange for data between each other, you're going to use data bus. If you want to do a controlling between CPU and also your your memory, so you're going to use your control bus. So this is just an overview what is basically happen inside your computer. And you can see also you have your register. Where is it? Where is my mouse? Okay, you have register, and you have also your CPU. Inside your CPU, this is your CPU of course. Under your register, you have ALU, control unit, and your clocks. Later on you will see this is 3 elements that are needed in your CPU. I guess we already look also in our early chapter, chapter 1, chapter 2. Okay, that is under your block diagram for your microcomputer. And now this is the part that I mentioned. You're going to see 3 elements. You have clock. This one is a very familiar, right? You're familiar with this word, with this word, in your digital logic. You have clock. So you have clock elements over here, and the descriptions. You can see what is the functions of your clocks, and you can use your clock for what. So this is the description, which is to synchronize the internal CPU operations. And you have the control unit. Basically all these elements, all these tasks you already learn in module 2, module 1. I guess also available in your test 1. So you can see what is the function for your CU, which is coordinate sequence of your execute step. And you have ALU, what is the task, what is the process that are happening and be done by your ALU is perform arithmetic and a bitwise processing. Now you're going to see in the diagram methods. If I did not show you this part at above this, of course you're going to know, oh, this one is clock. This is the symbol for clock. This is how the clock look like. So you have this one is 1 cycle. This one also you already learned. It's no need for you to think much, because all of this you already look and learn previously. And you can see over here, synchronize CPU and your bus operation. This is the functions of the clocks. Next is your mission or your mission clock, which is cycle measurement time, is a single operation. If let's say you have until this cycle measurements, so this is the operations time, which is one single operations. And then you have clock is used to trigger event. Last time in your digital logic you learned that you're going to be trigger when you have a positive edge, or maybe you have your negative edge, then you're going to trigger your output. Okay, this one is under your instruction execution cycle, which for your CPU block diagram. This is simple, right? But of course, you're going to see, this is not simple. You have many things inside. Basically, this is inside your CPU. You're going to have your code cache, instruction decoder, control units, your register and ALU. What is basically happen when you have your programming? When you start your code, you can see over here you have the code, and you're going to store it inside your memory. Of course, you have your data inside your memory. Then you have the bus for data that are connected to all of the functions inside your CPU. So when you are running your code, it's going to like reading one by one. Every single of your code is going to be read one by one, right? So what happen is it's going to have the code cache first. Then it's going to read your instructions inside your code. It used as a instruction decoder. You're going to decode it. You're going to translate your instructions to be understand by your computer. Let's say you are having 1, 2, 3, 4, 5. You have 5 codes lines. You have lines, 5 lines for your codes. This is your code. Allah, okay. First, you're going to have your code cache. When you try to run, similar to when you open your words, you're going to have also your cache file. Whenever you basically save it, you're going to save in your temporary file first before you can save it using a similar file. Similar file. Okay, now you can see you're going to read it one by one. First, you're going to read maybe your first line. So it's going to try to decode what is the instruction over here. What is the instruction over here? It's going to use the functions of instruction decode to like convert your assembly language or your any kind of language to be understand. So it's going to be decode to be understand by your machines. Then it's going to be sent to your instruction pointer. So you already point it at first line. Then it will continue. But before that, you can see when you already finish one line, it also will send this instruction to your CPU, to your machines, to let's say generate whatever instruction that give. And over here, you will continue again. You already point at number 1. Then you will move to second line. You will do the second one, which is instruction decode. You're going to decode the second line, and you will send also to your CPU. and your instruction point will be changed also. It's going to change to second, and it's going to be loop until end of your code lines. Every single line going to be sent to your CPU also to process. So inside your CPU you have control unit, you have the register ALU, register and ALU. So in your control unit, what going to happen is you going to send it whether if it is a floating point unit. If not, it's going to be directly sent to your data cache, because you already save whatever data that will be stored after you are instruct and you are you process the line by line, the instruction you process. You can see this one, which is not like this. This is going to be flow from one line to another, from one line to another, without it revert back. But in your control, in your processor, CPU, you're going to see that it's going to be vice versa, which is it can be change to each other. You're going to send the instruction and your register will be give back to your control unit to process, and from register you can also use your bus system to give to your ALU, depending what is the depending on your instruction. If your instruction are asking you to use a register, then you're going to direct to register. Maybe also it's having a correlation between your ALU in your instruction. That's why you have this kind of error. Then you're going to store your data cache, of course. It going to have a correlation using the address bus to your code cache also, because you will see later on, you will see in your, I guess, 4.5 on your addressing. So this is only the simple flow for your CPU block diagram. No need for you to have an X, as long as you understand is. I don't think that you're going to be asked to draw this block diagram. Only this is a general informations about your CPU block. This is the example what happened in your memory. When you have the readings, you have your clocks over here, and then you have your addresses bus, and then you have, what is this? This is a read line and your data. There will be having maybe what happened, what is going to trigger your changes at your address, what is going to change your RD, what is going to change for your data. So this is under your memory read cycle. It's going to be not going to be fixed, but there will be a step that you're going to see flow of it will be fixed, which is from your cycle 1, cycle through 3 and 4. So multiple machine cycle are required when reading from your memory, because respond much more slower than your CPU when you want to directly read any kind of data, let's say, in your memory. So the step that are required is, first of all, what you need to have is cycle 1, address placed on address bus is called as ADDR. This one you're going to learn address in your 4.5, I guess. Okay, then you have a cycle 1, which is your red line. Red line, your RD. This one is set low to 0. Maybe you can see over here. And your cycle 3, you have your CPU wait for 1 cycle for memory to respond. And lastly, you have the cycle 4, which is your RD going to high. It's going to be changed to the high. Indicate that the data of your data bus is on. Okay. So you can see the flow first step, and then after that it's changed to 0, and your data then is going to be changed again depending on your data that available. So this is what happened. Now you can see over here how your program runs. So 4.1 also already occupy long in video. So I think if we reach 4.2, I will stop this video first and I will continue in next video. Okay, how program run. So you have assembling, linking, running. So you have 3 steps, 3 phases that you're going to do. What is happen when you have your source file, you have your source code, your file, you're going to do assembler. This one is under assembly language. If you want to change your assembly language to your machine language, of course you need the assembler, right? This one we already look, and you can see your assembler. It's what your assembler will do. It's not directly convert it into your machine's language, but on top of it, basically there is a several step happen. Your assembler first will create your LST, your list file. So what is your list file? If you try to run your code, your assembly code, maybe you can try to look into your folder. Is it there is available of any file called as lst lst. So this is a listing file. Okay, so now you can see over here you have a listing file. This one was created by your assembler. So what is inside the listing file, later on you will see. So next step, what happened? Your assembler will change it into object file. Your source file will be changed into your object file using your assembler. So assembler did two things. One is creating the listing file and convert it into the object file. So from object file, you will see that you will have to link your object file to your library using your linker. That's why if you didn't have your library installed on your computer at the specific part, then you cannot execute your file. It's going to become out an error and etc. because you didn't have your linker. So your object file will use the linker to also create 2 files, which is first is your map file, as mentioned, similar to listing file. We're going to look into what is inside your map file later on. And you can see you also create an executable file. This one is normally you will get exe file and etc. This is executable file that you can execute. And when you execute this file using your programming, sometimes you cannot see basically what is what is file that created. Normally you're going to see only, okay, there is an output at your terminal, because your OS, what is OS? Your Windows, your operating system, your Linux bases, uh, will do a loader. It's going to load your executable file to be an output. So this is the flow, what is happen when you run your programming using your source code file. Okay, you can see over here the diagram describe the step by step from you creating your source program through executing the compiling program. If the source code is modified, let's say you modify one line, even one line, you cannot directly debug. You cannot directly debug or compile. You need to repeat again. You need to do from the first step. You need to compile, and then later on you're going to debug. So you need to go back to your step 2, which is assembler, until the end of the process. So it's going to be repeat if you did some modifications in your source file. Okay, I move to the next slide. As mentioned in your listing file, in your map file, going to see what is inside. So under listing file, why you need to have listing file? So the purpose of listing file is for you to see how your program is compiled. So maybe you can try to find now, open your folder and find the file called as .lst and check what is inside. You open using your notes notepad, then you can see its content. First, source code, your address, your object code, your segment name, and lastly your symbols, which is contain your variables, your procedure, and also your constant. So this is inside your listing file. So if you try to open, then you can see the overview much clearer. Okay, this is the example of your source code .asm, but normally you're going to see on your right, only right. You did not see what is basically the offset, the address, and etc. So now you will going to learn what is basically also happen behind your source code. Okay, whenever you have your source code, you can see you're going to start with your dot code, and then you're going to start your instruction after your main program process. You can see over here what is in your the most left over here. It is the 32-bit addresses. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So you have 32-bit addresses. Kenapa saya tak boleh tulis? 1 word, 2 word, 3 word, 4 words. And you can see over here, indicate the relative byte distance of each statement from beginning of the program code. It's going to start from beginning, but sometimes you can check it's not started at 0, 0, 0, 0, 0. So it's depend on your system. Sometimes you already occupy on the register, then that's why your addressing will start different value. Okay, now next what you're going to see, your dot code, your main program, it is not yet start because it's have nothing, no executables instruction at all. So you're not going to occupy any space. It is just a directive. It's not going to occupy any space. That's why it is 0000. Your address did not change at all. When you start your line of your addresses, then it's going to occupy you depending on the size that are mentioned, whether it is a words, maybe it is a byte. But over here it's not showing you byte or words or double word, but throughout over here you have EAX. I already give you extra notes, right? If EAX, it is a 32 bits for your register. You're going to have also your AX, which is 16 bit. You can have your AH, your AL. This one is 8 bits, 8 bits. So if you know all of these, then no need for you to mention anything like byte, words, double words, because this is already mentioned. You occupy 32 bits. Okay, and what else? You can see also here you have assembly language instructions, each of 5 bits long. Okay, over here you can see you're going to start at 00. Aduh, sikit lah. You have start at 00. Then next is 5. Basically you have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So you have 6 basically in your how long that occupy. Then you can see this is the value. The hexadecimal value is the second in your second column. This is your second column, this is your first column, which is B8 0001000. This is the value, and you put it which is the actual instruction bits for your first instruction. Then you're going to see you have next instruction line, which is add EAX 40,000 hexadecimal. So this is the value. Then you're going to see its changes in the addressing size. From 0000, you're going to move to 000005. So what happened? You have 00. Normally you have this one, right? And then 01, 02, 03, 04, 05. So all of this you can see that you are having this. So you're going to tag like 000001, and then if it is 32 bits, how many bytes that occupy for 32 bits? So you're going to occupy until 32 bits. I forgot to change it 32 bits. So how long you're going to store into your register EAX? Then you're going to change to your third line, fourth line, etc. It's going to save into your register value. And what happened is it's going to be changed following your addressing size. Okay, that is under your .asm file. Now you have another file that created. This file is created by I want to delete. Okay, this file is created by your linker. You can see over here your map file. So we're going to see what is exactly inside your map file. If you check your folder, maybe you can try to figure out and find out where is .map, and you open using your notepad. You open using your notepad, you're going to see what is inside the file. Okay, what is inside the file? The elements that have in your map file is starting address. This is the starting address. And then your end of address, maybe this is your end of address. Your size, where is your size? And you have also segment type. So you have length, and then your segment type over here. This is starting address, this is a stop address for each of your codes, line by line. Okay, now you already look into LST list files and also your map file. Don't just look into these notes. Please try to find the example of your .map and .lst file in your computer. Try to run and then try to find in the file that you are saved for your source code, for your Visual Studio Code. Okay, now we have the design detail for instruction set. When a computer architecture is in the design phase, the instruction set format must be determined. You need to determine first before many other decisions can be made. And selecting the format is often quite difficult because the instruction set must match the architecture. And the architecture is well designed. It could last for decades. So this one is under instruction of set. If you want to design, for doing the design decisions. This one is under ISA level. What is ISA? It is an instruction set architecture. So you have ISA level, which is define the interface between compiler, which is your high level language, and the hardware. It is a language that both them can understand. So this one, ISA level, which is the interface between your compiler for your high level language. Let's say you have this language for 1090, and then you have C programming. You're going to compile first, and before you will convert it into your machine's language, you can also just use the ISA level interface. That this one will execute it by using your microprogram or the hardware. So this one is under your software. Of course, your program is a software, and then you have the hardware to execute your programming. So this is what happened, and what is the use for your ISA. Okay, under instruction set architecture, still you're going to measure by different factor. First, you can see you're going to differentiate using the amount of space that the program require, and then your complexity, the length of instruction, and lastly total number of instructions. So this is the 4 factor. You need to memorize it, the 4 factor for ISA to be measured. Okay, that is under our 4.1 only for the instructions for your module 4. So now I'm going to stop first this video. I'm going to continue it in different video. We're going to look next video on our 4.2. What we're going to look is element of machines, instruction representation, instruction type, number of addresses, and instruction set design. So thank you for watching this video for our 4.1 instruction under module 1. Meet again in a next video.